Okay, let's look at the homework 2, problem number 4. Right? So we're going to use the ratio test to show that the binomial series converges for absolute value of x is less than 1. Right? So let's do that. Right? Remember that the binomial series goes something like this. You have quantity 1 plus x raised to the some power p. Right? This can be written as summation n goes from 0 to infinity. Then you have a binomial coefficient p, choose n. Then you have x to the n. Right? Then remember that the binomial coefficient, so where p choose n is just defined to be p times p minus 1 times and so on all the way to p minus n plus 1, right? And then divided by n factorial. Alright, so let's do a ratio test on this guy. Right, so this is going to be our an. Alright, so this is our an. Alright, so an plus 1 is easy to come up with, right? So an plus 1 is going to be p. So every time we see n, we put n plus 1. Choose n plus 1. And then you have x to the n plus 1. Right? So let's write it out. Alright, so ratio test. So we're going to have to do a limit of absolute value of an plus 1 over an. Right, as n approaches infinity, right, then this is equal to limit as n approaches infinity, right, absolute value. Alright, so let's write an plus 1. So an plus 1 is this guy, so the binomial coefficient, so it's going to start from p, and you have a p minus 1, and so on, all the way to p minus n plus 1, and also p minus n. Right? And then you're going to have n plus 1 factorial on the bottom. So you have n plus 1 factorial. And also you have x to the, maybe I'll put it here, x to the n plus 1. Right? Then we have to divide by an. So we're going to have to put the reciprocal of this guy. So this is going to be, you're going to have, right? So take the reciprocal of binomial coefficient. So you're going to have p times p minus 1 times all the way to p minus n plus 1. Right? Then you have also x to the n. So we put x to the n. Right? Then on top you have n factorial. Right? Then put the absolute value sign there. Alright, so let's cancel all the factors, common factors we can. Right? So first you have p cancel with p on the bottom. You have p minus 1, and everything in between, and p minus n plus 1, and you have p minus n plus 1. And also n factorial. So n plus 1 factorial is same thing as quantity n plus 1 times n factorial. So I'm going to cancel with n factorial, and I'm going to just strike out factorial there. So you have n plus 1 on the bottom left. And then also you have x to the n here. You have x to the n plus 1. So 1x left, so I'm going to strike out the power so that we know that this guy is left over. Alright, so then clean it up. So you're going to have, alright, so x has nothing to do with limit n, so I'm going to just pull that out. So absolute value of x is pulled out. Then we need to take the limit as n approaches infinity, and this is going to be absolute value. Alright, on top, so x is already taken care of, so what's left is p minus n over, and so let's so I took care of this guy, and I took care of this guy, and nothing left on top. And on the bottom you have n plus 1, and it looks like that's the only guy we have left on the bottom, so n plus 1. Alright, so in order to take the limit, I'm gonna just I'm gonna divide top and bottom by n, so 1 over n, and multiply by 1 over n, and that way we can take the limit a little bit more easily. So absolute value of x, you have a limit as n approaches infinity. Alright, so you have absolute value sign, so you're going to have p over n minus n over n is 1. Alright, so n divided by n is 1, and 1 divided by n is 1 over n. Alright, then n is going to infinity, so p just a finite number. P divided by really big number approaches 0. 1 divided by really big number is going to approach 0. So what's left is a negative 1 over 1, but with the absolute value sign, this is going to be 1. So it's going to be absolute value of x times 1, but that's just the absolute value of x, right? And remember that we get a convergence because this is mimicking the R value of the geometric series. So ratio test, as long as this guy is less than 1, we know that you're going to have a convergent series. So convergent, right? So therefore, we know that binomial series is convergent when absolute value of x is strictly less than 1. Right? That's it. I hope that this was clear.